Welcome to this second virtual class in chapter number 6, Acids, Bases, and Solutions. And in this case, we are going to be studying about lesson number 2, Concentration and Solubility. Concentration, the amount of solute relative to the amount of solvent or to the total amount of solution, can be expressed in several ways. The simplest is the percent by mass or volume of solute in solution. Concentration can also be given as the mass of solute in a given amount of solvent or solution. The maximum concentration of a solute in a given solvent at a particular temperature and pressure is called solubility. The solubility of a solute and the rate at which a solution forms can change with changes in temperature and pressure of the solvent. The solubility of a liquid or a solid solute usually increases with an increase in temperature. The solubility of a gas solute usually decreases with an increase in temperature. An increase in pressure increases the solubility of a gas, but it has little effect on the solubility of a liquid or a solid. The solubility of a solute also depends on the nature of the solvent. Polar solutes tend to have higher solubility in polar solvents, and non-polar solutes tend to have higher solubility in non-polar solvents. In addition to water, which is polar, alcohols, which are mildly polar, are widely used as solvents. The first important terms or definitions that we should study in this case are the ones better known as dilute solution and concentrated solution. A dilute solution is a mixture that has only a little solute dissolving a certain amount of solvent. A concentrated solution is a mixture that has a lot of solute dissolved in the solvent. The sap, for example, is a dilute solution, and the syrup is a concentrated solution. A solution can be described in terms of the amount of solute dissolving a given amount of solvent by using the terms dilute and concentrated, right? A dilute solution has only a little quantity, okay, a little solute dissolving a certain amount of solvent. So in this case, that will be your glass number 1, okay, on the left side of this image. A concentrated solution has lots and lots of solute dissolved in the solvent. That will be glass number 5 to the right side of this image. So because the amounts of solute and solvent can be varied, the concentration of a solution can be changed by adding solute or by adding or removing solvent. So, for example, if I ask you, how do you make lemonade from frozen concentrate? In this case, the obvious answer will be that we are going to be dissolving the concentrate in the suggested amount of water. So suppose you find the lemonade too strong. How can you reduce the concentration? So our basic answer will be that we are going to be adding more water, which in this case is the solvent. But another question, how could you increase the concentration of a solution without changing the amount of solvent? Well, in this case, the correct answer will be adding more solute. And if I ask you, how can two solutions have the same concentration if one solution has twice as much as solvent? Well, in this case, we can say that the solution must also have twice as much solute. This can be helpful in describing a solution. The terms dilute and concentrated do not provide any quantitative information or information about how much solute is dissolved in how much solvent. You know that maple syrup is more concentrated than maple sap, right? What is the actual concentration of either solution? To determine the concentration of a solution, we have to compare the amount of solute to the total amount of solution. You can report concentration as the percent of solute in solution by volume or mass. So as you may see on the image in this slide, you can talk about percent of mass and percent of volume. This is going to be depending on whatever it is going to be your solvent, okay? In this case, for example, if you're going to be trying to calculate the percent of mass, you're going to need the information of how many grams of solute do you have, and you are going to divide this by the total grams of solution and then multiply it by 100. But what if the formula for calculating that you're looking for is talking about volume? So the percent volume is going to be how many liters of solute will you have in a total amount of liters of solution? And that you're going to be multiplying as well by 100. You have to remind that concentration can be expressed as a percent, a part to whole. So in this problem, for example, and the one that you have is the one that you have on page 206. Go to your book and look up at the image that you have there from a contact solution. In this case, you have there that to calculate concentration, you have to compare the amount of solute to the amount of solution. So for example, here, they are telling you that you have 100-gram solution that contains 10 grams of solute and its concentration is 10% by weight. 10 grams divided by the 100 grams times 100 is equal to the 10% that you have there. So, to calculate or to determine the concentration of the contact solution, well, in this case, you go to the grams of solute, which are 10.7, right? Because you can get that information from the image on your book. And you divide that 10.7 grams divided by 355 grams, which is the total amount of the solution, right? And you're going to multiply this by 100, and the answer will be 3%. And that is going to be the concentration of the contact solution that you have on the image on page 206. So now if we get to study and ask ourselves what factors affect solubility, well, in this case, we should be thinking immediately about pressure. We should be thinking about the type of the solvent that we are going to be using. And obviously, we have to think about temperature. You have to remember, kiddos, that solubility is a measure of how much solute can dissolve in a solvent at a given temperature, right? But we have to give like more importance in this case to the phrase at a given temperature. Okay, repeat with me. At a given temperature. Okay, why? Because you have to understand that solubility varies with certain conditions. Solubility depends on three factors. Again, pressure, the types of solvent, and temperature. You have to distinguish between a saturated solution, okay, and an unsaturated solution. When we talk about a saturated solution, we are talking about holding all the solute it can at a given temperature. No more solute is going to be able to dissolve. And when we talk about an unsaturated solution, we're going to be understanding that more solute can be dissolved still. Remind yourselves, please, that solubility is a physical property of substances. Thus, it can often be used to identify an unknown substance. So, question number 1, and this is going to be for homework. How can you tell when you have reached the solubility of salt in water at a given temperature? Question number 2. How will the salt water solution be described at this point? And question number 3. What could be done to get more salt to dissolve in the solution? Question number 4, and please look at the table on figure number 2 on your book. Which compound has the highest solubility at 20 degrees Celsius? So you have there 4 questions that you're going to do for homework. We have to reinforce the idea that the rate at which a solution forms also depends on a variety of factors, including, for example, particle size, temperature, and stirring. If we get to ask ourselves if will sugar dissolve faster in hot tea or in iced tea, well, the right answer immediately will be that it will be dissolving faster in a hot tea because the higher temperature speeds the rate at which the sugar dissolves. So how can you speed up the dissolving of sugar in iced tea? Well, in this case, it's really easy. Stir the tea, right? Use the sugar that has been finely crushed.
Solubility and concentration aren't enemies or anything. They're just two chemistry terms we use to describe solutions. Let's start with concentration first. So, let's say that we took simple table salt, sodium chloride, and we're going to put it in water. Well, in this situation, sodium chloride would be our solute, what we're putting something into, and water would be our solvent. Whatever we have more of, we put the solid in the liquid. That's usually how it works. Solute, solvent. So our concentration, let's say that we had 10 grams of sodium chloride and we had 100 grams of H2O. Then our concentration would simply be a ratio. So 10 grams sodium chloride over 100 grams H2O. But we usually don't use these units. We usually use something that denotes volume for the solvent. So a more typical way that we'd see it is 10 grams sodium chloride for every 100 milliliters of H2O. Remember that for water, grams and milliliters have a 1-to-1 conversion, so we can just do this. And this would be something typical that we'd see for concentration. So let's look at solubility now. Solubility is the ability of a solute to dissolve in a solvent. So if it dissolves, it's soluble. If it doesn't, it's not. So we know that salt will go into water, and let's examine why. When you put salt into water, it actually dissociates into ions, and the ions are positively charged sodium and negatively charged chlorine or chloride. Now water has a chemical structure of H2O. Draw a couple of guys in here, and remember, in solution, every sodium and chlorine ion would be completely surrounded by water. So I'll just draw in a few here, but it's actually going to be completely covered by different waters. So water has a strong dipole because oxygen is so electronegative and hydrogen is so electropositive. So every water atom we have has 3 partial charges, 2 partial charges of positive on the hydrogens and 1 partial negative on the oxygen. So we know that positive and negative charges are attracted to each other, so this positive sodium ion is going to be attracted to this partial positive oxygen atom. Now the exact opposite is going to have here with chlorine. So you have a partial positive hydrogen, that's going to be attracted to your negative chloride ion. And this is the reason that it's soluble, because the interactions between water and the ions are strong enough to separate the interactions between the ions, at least when they're in solution. So if we have something else, for instance, just like a rock that we put in water, the bonds in the rock are too strong amongst themselves to ever dissolve and let water get in the middle. I'm Robin Higgins, and that was solubility versus concentration.